Hi guys and welcome. This is a series in mathematics for both grade 9s and grade 12s, and our topic of study is matrices, mathematics that is. We're looking at matrices, and so far we've done quite a lot, so I would urge you to catch up. The last thing we did was multiplication of matrices, so now we move on to more interesting things, and in this video we'll look at identity matrices, we'll look at the inverse of matrices, we'll look at the determinants, and we'll look at how we can divide matrices. So unlike multiplication, for division of matrices, we need to get an idea of all these things that I've mentioned. We need to know how to find the determinant, we need to know what an identity matrix is, we need to know how to find the inverse of a matrix, and then we can divide matrices. Okay, so let's see how we can divide matrices. Sorry. Okay, let's get into it. So first and foremost, we need to know what an identity matrix is. What is an identity matrix? In one of the past videos, we looked at what square matrices are. We said a square matrix is a matrix that has the same number of rows as columns. So if it's got 2, 3, 4, 1, this is a square matrix. Am I right? Yes. If it has 3, 1, 2, 4, this is 4, forgive my 4, looks like a 4, yeah, 1, 0, and also if we have 1, 2, 3, this is a 3, 4, my handwriting is pathetic today, 5, 6, 7, 8, 9. Okay, so is this a square matrix? Yes, it has 2 rows, 2 columns. It's a 2 by 2 matrix, therefore it's a square matrix. Is this a square matrix? It has how many rows? 2 rows. How many columns? 3 columns. So this is not a square matrix. Is this a square matrix? It has 3 rows and 3 columns. So yes, it is a square matrix. Okay. So glad we are together on that. Glad we are on the same page. So now we can look at what an identity matrix is. An identity matrix is simply a square matrix that has only 2 numbers, only 2 different numbers in it. So it has zeros and it has ones. So it's a square matrix that only has 2 numbers in it. It's got zeros and it's got ones. So let's take for instance, we have a square matrix, a 2 by 2 matrix, which is a square matrix, and it only has zeros and ones. So we've got 1, 0, okay, 1, 0, 0, 1. This is an identity matrix. So for any matrix to be qualified as an identity matrix, it needs to be a square matrix. These are the conditions that I'm giving you. So let's say identity matrix. The conditions for it to be an identity matrix. Firstly, and most importantly, it should be 1 square matrix, square matrix, square matrix, and 2 should only have zeros and ones, and ones. Okay, then the third and very, very important condition is that the ones should be arranged in a diagonal. So ones should be diagonal. Ones should be diagonal. So let's look at the example that we have. We have 1, 0, 0, 1 are the ones that we have in this square matrix diagonal. They are diagonal in that they are like that. So the ones should satisfy that condition and be in a diagonal arrangement. So if we have a different matrix, let's say we have this square matrix 1, 1, 0, 0. Does this matrix qualify to be an identity matrix? No. What if we had this matrix 1, 0, 0, 0, 1, 0, 0, 0, 1? Does this matrix qualify to be an identity matrix? So it's a square matrix, yes. It only has ones and zeros, yes. It has satisfied these two conditions. And finally, does it have its ones in a diagonal? Well, let's look at the arrangement of the ones. The ones are all in a diagonal arrangement. So yes, this is an identity matrix. And you can look at so many different examples and try to see if whether those examples that we might have are identity matrices or they are not identity matrices. So this is a very important concept that you need to understand. When you multiply any matrix by an identity matrix, to give you the same matrix that you have. Similarly, when we're dealing with numbers, just these normal numbers, if you say 2 multiplied by 1, 2 multiplied by 1 gives you a 2, and 3 multiplied by 1 gives you 3. 100,000 multiplied by 1 gives you 100,000. So in matrices, an identity matrix is a 1, meaning if you have, another important thing before I get to that is identity matrices are simply denoted by an I like that. So if you have, let's say, matrix A multiplied by an identity matrix I, it should give you A. If you have matrix B multiplied by an identity matrix I, it should give you matrix B. Okay. So I would have loved to go through examples and just try and prove this theory, but it's just important that you know what identity matrices are, and you will rarely be examined. I don't think you'd ever be examined on proving to say is this an identity matrix or not. But otherwise, you can try it on your free time, and just try multiplying different matrices by identity matrices, an identity matrix, and you find that your answer will always be the same matrix that you had initially. Okay, so now that we know what identity matrices are, we can move on to another interesting topic, another interesting aspect of matrices, which is known as the determinant. Determinant, I don't know how you pronounce it, but the spelling is Determinant, determinant of a matrix. Okay, so as far as we are concerned, as grade 12s and as grade 9s, we will only our syllabus only goes as far as finding the determinants of a 2 by 2 matrix. Okay, so we need to know how to find the determinants of 2 by 2 matrices, 3 by 3, 4 by 4, and all those other matrices that we might think of. We will never be asked on how to find, how to evaluate their determinants. So very important that we need to learn how to determine the determinants of a 2 by 2 matrix. What is a 2 by 2 matrix? A 2 by 2 matrix is one with inputs A, B, C, D. It has 2 rows, it has 2 columns. Okay, so all this is leading to something that we will eventually learn, and that is division of matrices. So you need to understand how to find the determinant of a matrix. Okay, So let's get into it. So let's say we are given a matrix. Let me just get rid of that. Let's say we're given a matrix, matrix A. And this matrix A has inputs 2, 4, 1, and 7. And you're asked to find the determinant. So you're asked to say find determinant of A, of matrix A. How do we go about finding the determinant of a matrix A? So if we look at this 2 by 2 matrix that we have, it has four different numbers. Okay, 4 numbers that are in different positions. We've got that one, got that one, got that one, got that one. So this matrix has 2 diagonals. Okay, it has 2 diagonals. We've got this diagonal, which is from there to there. This diagonal has 1 and 4 in it. And then we've got the second diagonal, which has 2 and 7. Okay, do we see that? I hope we do. So this matrix has 2 diagonals. We've got the diagonal that has 2 and 7, and we've got another diagonal which has 1 and 4. So there's what is known as the major diagonal and the minor diagonal. The major diagonal is the one with 2 and 7, the one with the first number that you have, which is 2, and it has 7 on the other end of the diagonal. Then the minor diagonal is the one with the 4 and the 1. So major diagonal, minor diagonal. Get that into your head. Major diagonal, minor diagonal. So to find the determinant of any matrix, it is given by product of major diagonal minus the product of the minor diagonal. Okay? Product of major diagonal minus the product of the minor diagonal. So let's see what we mean. So in this example that we've been given, our major diagonal is 2 and 7. So the product of 2 and 7 is simply 2 multiplied by 7. So brackets are very, very important in mathematics. They help you distinguish your work. They help you see clearly what you're doing. So minus product of the minor diagonal, we've got 4 and 1. Brackets again. So what is 2 multiplied by 7? 2 multiplied by 7 gives you 14. Minus 4 multiplied by 1 gives you 4. 14 minus 4 gives you 10. So this is the determinant of matrix A. Okay, another example. Let's say you've been given matrix B. Matrix B has 6, 3, 2, and 5. And you're asked to find the determinant of matrix B. So determinant of B is given by what values do we have in our major diagonal? What values do we have in our major diagonal? This is our major diagonal. And what values do we have in our minor diagonal? This is our minor diagonal. Okay. So to find the determinant of B, we'll say product in the major diagonal minus the product in the minor diagonal. So we're going to have 6 multiplied by 5, brackets, very, very important, minus 3 multiplied by 2. 3 multiplied by 2, brackets. What is 6 by 5? 30. What is 3 by 2? 6. So 30 minus 6 gives you 24. So therefore the determinant of B is 24. Okay, I hope we've understood the concept of finding the determinant of 2 by 2 matrix. Very, very important, and I would advise you to look for questions and just try finding the determinants of different matrices. You can make up matrices of your own. as long as those matrices are 2 by 2 matrices, and try finding the determinants all by yourself. Okay, I really thought we would go as far as division, but let's end here for now, and let's move on to the next video. In the next video, we'll look at how to find the inverse of a matrix and how to divide matrices. Okay, thank you very much.